my pleasure to introduce to you Dr. Richard Bellon. Dr. Bellon is a historian of science at Michigan State University, just down the road from us here. He's got a joint position with Lyman Briggs College. He's in the Department of History, and his research expertise is in British history, and he's going to be talking to us today about the connections between Herschel and Darwin. So, Dr. Bellon, all yours.
Well, thank you very much. I'm really excited to be here and talk about research as part of a larger research project where I'm trying to understand the place of science in 19th century British culture and focusing on Darwin, but not just on Darwin. And in particular, actually my little thing died here. Just a second. So one of the things that is looking at sort of Darwin. Now, for most audiences, Darwin is the person that everybody knows. That, let's see. But I actually particularly like talking to this audience because will know very much the other sort of major character in today's talk. And that is sort of John Herschel. I mean, John Herschel is not on the money in Britain. He does not have the current profile, but that is relatively recent, at least relatively recent sort of historically. If you go and you look at the Ngram viewer, I mean, Google Books has this wonderful tool where you can put in search terms and it'll tell you kind of the relative frequency of these terms in books over time. And so this, you can see, is the red line is Charles Darwin and the blue line is John Herschel. And so what you can see is that during the 19th century, Herschel was a much more significant figure than Darwin. And it wasn't until the 20th century that Darwin really begins to eclipse Herschel. But what you can see happening is less Darwin taking off and more sort of Herschel beginning to fade. That said, he still remains a very sort of significant sort of historical figure. And what I want to look at today is the relationship between Darwin and Herschel and the importance of sort of Herschel for Darwin's theory, but also as a way to understand the significance of what Herschel was doing in the 19th century as well. And to start with, I want to go to July 1802. This is when Herschel was 10 years old, and it was an exciting time because for the first time he was leaving Britain. That with his father, his mother, and a cousin, they were leaving Britain and they were going to Paris. And the reason that they could do this is the Napoleonic Wars, at this point, was a brief lull. It wouldn't last. The wars would resume, but for a brief time, you could visit Paris if you were sort of British. And so a lot of people from Britain did so right around the same time. In fact, the Herschels are going. The great painter John Turner, a few days earlier, had also embarked for Paris. And so this was not just for the Herschels, we're not just sort of tourists. William Herschel was not just going to Paris to see, he was going to Paris to be seen. He was invited by the French, the great and the good of the French scientific establishment. And the reason for this is that by 1802, William Herschel was the greatest observational astronomer who had ever lived. David Brewster in the 19th century said that you can divide the history of observational astronomy into two parts: everything that came before William Herschel and William Herschel. So an incredibly significant individual. I mean, one of the things that's really, I think, kind of amazing is that he was, one of the things that made him such a good observational astronomer is he was a great instrument maker. And he had the best instruments in the world. So now the notion that originally an amateur astronomer could have the better instruments than NASA, I mean, that seems remarkable. But that what Herschel was able to do is to build these telescopes that allowed him to see more reliably into the heavens than anybody had ever done so before. And he did this with an incredible amount of skill and diligence. And of course, the thing that really catapulted him to the absolute sort of top of kind of the scientific establishment was an observation he made of what appeared to be a comet. And so he noticed this, and one of the things that he noticed is the motion of this particular comet was particularly unusual. He keeps following this in 1881, and eventually what he realizes is that this is not a comet at all. This is a new planet. So this is the first planet discovered since antiquity. He called it, in a wonderful example of kind of branding, Georgium Sidious, George's star after the King of England. We now, of course, know it as Uranus. And so when he made this discovery, there was at first anyway, the assumption that there's, this astronomer that nobody ever heard of had simply got lucky. But in fact, that's not the case at all. That Herschel was an incredibly talented sort of astronomer, and he was able to greatly expand our knowledge of the heavens, particularly in his studies of sort of nebula. The amount of nebula that he discovered during his lifetime was absolutely sort of astonishing. And so when he's coming to Paris, he's coming as a very sort of justly celebrated figure. So this is the Tuileries, so this would have been Paris when he arrives. And one of the people that he very much wants to meet, and very much wants to meet him, was the only astronomer at the time that really would have had Herschel's reputation. But it was a different type of reputation. This is Pierre-Simon Laplace. If William Herschel was an absolutely brilliant observational astronomer, it is Laplace who was the great mathematical astronomer. He's the person who could calculate the motions of the heavens with an incredible amount of sort of sophistication. And so when Herschel arrives in Paris, this is when Laplace is starting to publish what would eventually be 5 volumes of his masterpiece, Celestial Mechanics. And this would set forward a basic sort of understanding of the operation of the solar system at a high level of mathematical sophistication. But the thing that even before this, that was one of sort of Laplace's great accomplishments, was to deal with a problem that had really bedeviled astronomers really since the age of sort of Newton. So here you can see kind of an idealized image of the rotation of the solar system, and you have Jupiter and you have Saturn, and of course using sort of Newtonian laws, you would be able to sort of comprehend kind of where the planet should be at any given time. And so you had Newton's theory, but you also had centuries of sort of observations. And here was a real problem, because one of the things that the observations indicated is that Saturn was slowing down in its orbit. Jupiter was speeding up beyond what you'd predict through basic sort of ideal sort of Newtonian sort of motion. And this presented particular problems. Not only were they unable to account for this, but this had kind of really rather significant physical characteristics, because if Jupiter is going to slow down, eventually, let's see if we can get this to work. If it's going to continue or Jupiter's going to continue to slow down, eventually the orbit is going to decay. In fact, I remember telling my wife about this. I got really sort of excited, and then Jupiter's going to crash into the sun, and she kind of looks at me and says, well, you know it's a gas giant. It would like evaporate, right? So, sure, but whatever happens, this is not good for the stability of the solar system. Meanwhile, poor old Saturn the orbit is elongating and is essentially sort of escaping. And so this presents a real kind of problem. And you had some of the greatest 18th century mathematicians are trying to solve this, and they weren't able to solve it. And so the person that eventually was able to solve this was Laplace himself. I don't have the mathematical sort of wherewithal to kind of work through exactly how he did this, but the conclusions are quite clear. What he was able to demonstrate is that it was only a sort of an artifact that Jupiter seemed to be going faster and Saturn was starting to go slower of a much larger sort of cycle. What he was able to demonstrate that in a 950-year cycle, both planets would speed up and slow down. However, if you take their sort of average speed over the course of that entire cycle, the speed would be exactly what you would expect according to sort of basic sort of Newtonian predictions. And this is really quite important. I mean, this was a great mathematical accomplishment. It solves a really difficult mathematical and physical problem in celestial mechanics. But what also it does is it provides Laplace with a really quite interesting sort of philosophical judgment about kind of the nature of the universe. And so as he argues in his sort of paper on this, he said that the system of the world merely oscillates around a mean state from which it deviates very little. This stability of the system of the world, which assures its duration, is a phenomenon most worthy of our attention because it shows us in the heavens the same intention to maintain order in the universe that nature has so admirably followed on Earth to sustain individuals and to perpetuate species. And so one of the things, as a kind of a historian of biology primarily, that this really sort of excited me when I came across this, and this is not an obscure quotation, and I'm rather amazed that nobody has ever kind of picked this up, because he's talking about the stability of the system also maintaining the stability of sort of species. Now, Laplace was an astronomer, he was a mathematician, he wasn't a biologist, so I think you can see this as a throwaway line. You don't want to put too much philosophical weight on this, other than kind of the basic assumption that the universe it has basic qualities of order and design and regularity, that you don't see runaway variables, that the same way that you see in the solar system maintaining regularity, you see this also on Earth in terms of the regularity that we can expect to see on Earth as well. And as I'm going to argue, this has a very big consequences. Now, so while the Herschels are there, Laplace was able to introduce William Herschel to none other than the Emperor of France, Napoleon Bonaparte. In fact, Laplace and Bonaparte were quite close. For a while, Laplace was actually Minister of the Interior of France, although pretty soon everybody realized that being a great mathematician and running a government bureaucracy are different skill sets. And so that didn't work out really well for Laplace, but still, he was able to sort of hang out with sort of Napoleon, bring sort of Herschel, who actually thought Napoleon was something of a blowhard, truth told. But what's interesting is we have Herschel's own contemporary account of this particular sort of meeting. And so one of the things that he talks about is a kind of a friendly discussion that Laplace and Napoleon had about God and astronomy. And this is interesting because it maps very closely onto what is one of the kind of the favorite anecdotes of 19th century science. And so as the anecdote goes, and as this is really kind of confirmed by Herschel's firsthand account, Napoleon supposedly says, pointing to celestial mechanics, "I see no mention of God in this work," in which Laplace is reportedly said, "Sir, I have no need of that hypothesis." And so and in fact, this is important, because one of the things that in Laplacian philosophy that is maintaining the order of the universe, it's not the direct intervention of a god. It is, and in fact, that's what Isaac Newton thought. Isaac Newton thought that the solar system was maintained by God literally intervening and deliberately intervening. Laplace thought Newton must have been insane at that point. That for Laplace, its natural law can provide an explanation for all of the stability that we see in the universe. And again, as we'll see, that this is very important. And so young John Herschel, this is what he grows up on. Not just grows up with his father, and he becomes a very good sort of astronomer, very good sort of mathematician. In fact, one of the amazing things about Herschel's biography is that his achievements begin very young. As an undergraduate in Cambridge, at the time, Cambridge mathematical education was really quite poor, particularly compared to what was happening on the continent. And so Herschel was part of a group of undergraduates who began to reform the mathematical curriculum and successfully reform the mathematical curriculum of sort of Cambridge University. And it's not, I think, an exaggeration to say that what Herschel really wanted to come from this, from these reforms is he wanted the British to be, at least the ones who graduate from Cambridge, to have the ability to read Laplace's Celestial Mechanics. And so it's also, however, it's not just the mathematics, it's not just the astronomy, it's this view of nature. And it's a view of nature in which natural law provides sort of order that sinks very deeply into sort of Herschel's view of the universe. And we can see this, we can move forward to the next part and jump forward 30 years to the 1830s. By this time, Herschel is one of the leading men of science in Europe, and he is going on what is an incredibly celebrated sort of voyage to South Africa. And he's going technology. All right, let's try this. No, oops.
There we go.
Oh, well, we went too far. Okay. Now we're going too far. So it's a long voyage to South Africa, and the reason he's going is to carry out some original observation of the southern stars. And it also wasn't an easy sort of voyage. During the course of this, he writes in his diary about some of the things that he had to face.
After dinner, the ship began to roll, wind exactly aft, and it grew so dreadfully bad, though almost no sea running, that I hardly know whether it is not worse than the pitching motion in a heavy sea. It takes you unawares. After a long, still interval, the oscillations begin on a sudden to increase with slow, equable swing, till they acquire such an amplitude as to throw everything about off the tables, chairs, etc., higgledy-piggledy, and almost carry you off your legs. It is a terrible trial of temper, stomach, and understanding.
So, was not a fan of seasickness, was our John Herschel. And the reason I sort of bring this up, because this actually captures part of the kind of view of nature, because he's aware that, of course, that nature could have these oscillations and irregularities. But the important thing is that everything that he was suffering was governed by unified sort of natural laws. And it was ultimately natural laws that were central, and these types of oscillations and this higgledy-piggledy were kind of secondary effects. And that's something I will get to, the importance of that I'll get to in a little while. Now, when he goes to South Africa, he's not just at this point famous as an astronomer and as a mathematician, that he writes in 1830 his masterpiece. This is the Preliminary Discourse on the Study of Natural Philosophy. This is, I think today, despite the rather dull title, is a wonderful book. It's a book that captures not just how do you do science, but why do you do science. There is a real sense of mission and passion, and this book would have a profound influence on the way that scientists would think about their vocation for the rest of the 19th century. And so I want to sort of look particularly not just at the kind of the technical aspects, but some of the moral aspects, just to understand how it is that Herschel thought about science and nature and its moral importance.
Independent of the pleasures of fancy and imagination and social converse, man is constituted a speculative being. He contemplates the world and the objects around him, not with a passive, indifferent gaze, as a set of phenomena in which he has no further interest than as they affect his immediate situation and can be rendered subservient to his comfort, but as a system disposed with order and design. He approves and feels the highest admiration of the harmony of its parts, the skill and efficiency of its contrivances. Thus he is led to the conception of a power and an intelligence superior to his own, and adequate to the production and maintenance of all that he sees in nature. There is something in the contemplation of general laws which powerfully persuades us to merge individual feeling and to commit ourselves unreservedly to their disposal, while the observation of the calm, energetic regularity of nature, the immense scale of our operations, and the certainty with which our ends are attained tends, irresistibly, to tranquilize and reassure the mind and render it less accessible to repining, selfish, and turbulent emotions.
So right there you can see, first of all, how he merges science and sort of natural theology, his belief in God. But it's a God that creates through natural law. And it is the regularity of the system that we see God's sort of design. And so this, again, is very important. And I think this is where we can see this ideal of Laplace, of a regular, of the regularity of nature, begins to sort of be embedded in Herschel's own sort of understanding of the natural world, and through works like the Preliminary Discourse, much more generally into sort of British culture. And again, to focus on this a bit about the calm, energetic regularity of nature. That is absolutely central to understand kind of how Herschel viewed the world. And so it's also when he takes his telescope, carries out this immense and important sort of observation of the southern sky. So this is right on the base of the Table Mountains, right off of Cape Town. So a very physically beautiful sort of location. His house, Feldhausen, was a very sort of tranquil. But while he was there, he was not cut off from science as it was being practiced in sort of Britain. And in particular, he was interested in sort of geology. Actually, I'll get to that in a second. One of the things I do want to show you is that while he was there, he was a very good artist and would create these wonderful sort of panoramas of the landscape. So this is one of the sort of the panoramas that he sort of created. And one of the wonderful things about the dome is you can actually sort of reconstruct this from sort of Table Mountain, and you can see some of the ways what he would have been sort of viewing when he is in South Africa. You can see down on the coast that is Cape Town. And you can also see that there's the Southern Star. It's kind of actually kind of above you and maybe behind some of you. And so this would have been the kind of the sky at the time and the place that as he would have witnessed it when he was drawing this original panorama. And so as I was saying that he was not just interested in, he was not just doing astronomy, he was also corresponding with some of the leading scientists back in Europe, and particularly he was interested in, he was carrying out a conversation through the post with Charles Lyell, who had started publishing his work, Principles of Geology. And in Principles of Geology, Lyell deals with the question of the origin of species, and sort of it's anti-evolutionary, but it's kind of in a kind of a cagey type of way. Herschel's reading it and makes what is one of the real kind of famous sort of observation about the origin of species in the 19th century.
I allude to that mystery of mysteries, the replacement of extinct species by others. Many will doubtless think your speculations too bold, but it is as well to face the difficulty at once. For my own part, I cannot but think it an inadequate conception of the Creator to assume it as granted that his combinations are exhausted upon any one of the theatres of their former exercise, though in this, as in all his other works, we are led, by all analogy, to suppose that he operates through a series of intermediate causes, and that in consequence the origination of fresh species, could it ever come under our cognizance, would be found to be a natural in contradistinction to a miraculous process, although we perceive no indications of any process actually in progress which is likely to issue in such a result.
So you can see this is a piece with his general belief that God creates not through primary creation, but through secondary law. And here he's holding out at least the prospect that species themselves can be understood as a process, the creation of species as a natural process rather than a series of kind of rolling sort of miracles. Although he also says that what that process would be, he can't begin to imagine. Now, shortly after he writes this, a ship, British ship, HMS Beagle, goes into Simon's Bay. And it is this point that Charles Darwin is finally able to meet his hero. That Darwin reads the preliminary discourse when he is when he's an undergraduate at Cambridge, and he's absolutely sort of transfixed by it. If you look at Darwin's autobiography, he said that there are two works that influenced me more than any other. One is by the German naturalist Alexander von Humboldt. The other one is the preliminary discourse. It fired him up. He said it gave him a passion to contribute to science. And we can see this. We can trace Herschel's influence, the methodology that Herschel sets out in the preliminary discourse. This is what guides Darwin's scientific career to the day he dies. And again, Darwin isn't alone in that, but Herschel's influence on this particular young man was particularly sort of persuasive and pervasive. And so it was with a great deal of enjoyment that Darwin and Captain of the Beagle, Robert Fitzroy, were able to go to Feldhausen. This would have been their view out the window as they're talking to sort of Herschel. We have some idea of what they were talking about through letters. We don't have everything. Don't know WikiLeaks, I guess, of the 19th century. It's too bad. So we don't know if they're actually talking about the origin of species or not. There's a good case that they, in fact, might have been. But what we do know is that the young man and the established astronomer had a lot of sort of interests in common. And so this then kind of, from this meeting, brings us forward, jumping forward now nearly 30 years, into December of 1859. Now, by this time, Charles Darwin is no longer a young, untested, largely unknown naturalist. He is, at this point, one of the most famous scientists in the world, because in November of 1859, he publishes his work on the origin of species. And so it is in December, he is sharing a letter with Charles Lyell about John Herschel. And we're going to get to that in a second. But I want to talk a little bit about sort of the origin of species. And one of the things that you can see with the origin of species is that Darwin starts the book and he ends the book with Herschel in a very clear way, particularly in the introduction. This is the first. Page.
When on board HMS Beagle as naturalist, I was much struck with certain facts in the distribution of the inhabitants of South America, and in the geological relations of the present to the past inhabitants of that continent. These facts seem to me to throw some light on the origin of species, that mystery of mysteries, as it has been called by one of our greatest philosophers.
And so right there, for the very beginning, the mystery of mysteries. And it's important to point out that the letter where Herschel mentions to Lyell the mystery of mysteries, that is published. It's published by a friend of theirs called Charles Babbage of computing fame. And so anybody who, not everybody would have picked up the Herschel reference, but the people that Darwin most cared about, the scientific audience, would know that right from the very beginning, Darwin is talking about kind of Herschel and this mystery of mystery. He's alluding to this, at this time, well-known claim by Herschel that perhaps at some point we need to understand the origin of species by natural law. The end of the final paragraph of the origin of species, as I said, also ends on Herschel in a way that's not quite as direct, but I think is still incredibly significant.
Okay. There is grandeur in this view of life, with its several powers, having been originally breathed into a few forms or into one, and that whilst this planet has gone cycling on according to the fixed law of gravity, from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved.
Now, one of the things I always find interesting about this sentence, this is a famous sentence. I mean, I'm sure almost everybody's heard about the grandeur in this view of life. It's the bit about gravity and the planet going on, circling according to the fixed law of gravity. If you go through and you were to chop that particular passage out, you wouldn't miss it in the sentence. It doesn't seem to need to be there necessarily, but in fact it's crucial to Darwin's sort of rhetoric. What he's saying is that what he's doing with the origin of species is no different than what astronomers have already done, which is to explain natural phenomena through natural law. And so he is invoking the science of astronomy. He's in a sense invoking the astronomy of Herschel. In order to provide a grounding and a legitimacy for what he is trying to do. And so that then kind of brings us back to the letter that Darwin was writing to Herschel. But actually, before we get to that, there is one other quotation I want to share to also see that how Darwin thought about these issues in terms of theology.
With respect to the theological view of the question, this is always painful to me. I am bewildered. I had no intention to write atheistically, but I own that I cannot see as plainly as others do, and as I should wish to do, evidence of design and beneficence on all sides of us. On the other hand, I cannot anyhow be contented to view this wonderful universe, and especially the nature of man, and to conclude that everything is a result of brute force. I'm inclined to look at everything as resulting from designed laws, with the details, whether good or bad, left to the working out of what we may call chance.
And so what you can see here in one of the clearest statements that Darwin makes about his own kind of view of God and theology and its relationship to evolution, this is very Herschelian. It's seeing the world as created by the world as resulting from natural laws, and the natural laws having perhaps a divine author, but it's not divinity, it's not God working a set of miracles, it's God setting up the original boundary conditions of the universe and simply then allowing it to run, as Darwin said, as you might call chance. And so given his connections to sort of Herschel, he had high hopes that Herschel would be impressed. And it turned out he would be disappointed.
I have heard by roundabout channel that Herschel says my book is the law of higgledy-piggledy. What this exactly means I do not know, but it is evidently very contemptuous. If true, this is great blow and discouragement.
So Darwin's bummed, right? His hero calls his work the law of higgledy-piggledy. But I think, and Darwin's not quite sure what that means, I think that we can figure out what that means. And it's when Herschel 30 years earlier is referring to kind of the higgledy-piggledy of the waves. I mean, I think that tells us something very important, because for Herschel, that waves or biological variation, or all the type of things that seem to be sort of random. Randomness is merely sort of accident, that we understand the oscillations of the waves. We understand biological variation, if we are to understand it, as a result of a natural law that brings regularity. And what Darwin's doing is flipping the switch. He's saying that we understand the basic origin of species through the accumulation of random variables, through kind of runaway variables that just simply accumulate in random sort of directions. And for Herschel, this violates his basic sort of understanding of how the universe operates. The universe is governed by sort of regularity. It is not governed by sort of randomness, that any law of the origin of species has to explain away variation. It's not explained by it. And so we can see this, as I said, again, we go back to his, back to the difficult voyage from Britain to South Africa. Everything being thrown sort of higgledy-piggledy. Science is something that explains away, not explained by, higgledy-piggledy. And so it's the calm regularity of nature, which any good theory must use as its philosophical foundation. And as I would emphasize, that this is something that comes very clearly from Pierre-Simon Laplace. And I think one of the ironies of this is you can on one hand see Herschel's reaction to sort of Darwin's theory as the unfortunate effect of a now elderly scientist allowing his religious convictions to blind him to a sort of basic scientific truth. And I think that that's fundamentally kind of a mis sort of interpretation. Because what we can see here is that that it's a violation of Herschel's view of the universe, and it's a view of the universe that he doesn't get from the Bible. He gets it from Laplace, and he gets it from other scientists. And Laplace himself was a notoriously atheist. And also, going back 70 years, would focus on the stability of the system and also the perpetuating the species. And so this is why Herschel, despite Darwin's hope that Herschel would love what he did, remained always, in fact, deeply ambivalent, if not actually outright hostile to Darwin's achievement. And so let's jump forward now nearly another 30 years, and 1882. This is Charles Darwin's death and his burial in Westminster Abbey. And this is a clear sort of indication that the idea that Darwin is implacably hostile to religion and that these are irreconcilable, you need to think that, in fact, he's buried in a church. He's buried in the church because by 1882, the Church of England had long since made its peace with the theory of evolution, had long since made its peace with Charles Darwin. In fact, there was a remarkable funeral sermon by the Reverend George Prothero, who was a chaplain to Queen Victoria, who said that Darwin, in his humility and his patience, represented the true spirit of Christ. Now, that seems kind of remarkable now that anybody would say that Darwin represents the true spirit of Christ. That was not sort of unusual in sort of 1882. And so, if you visit Westminster Abbey, and I would highly recommend that you do if you're ever in London, you can go and you can visit sort of Charles Darwin's grave. And when people talk about Darwin's grave, they often talk about it in the proximity to the grave of another great English scientist, Isaac Newton. But I would say that if you really want to understand sort of Darwin, and you really want to celebrate what he did and understand what he did, is don't look to your right for Newton, but you look to your left. And you'll see that buried next to him is John Herschel, who, in death as in life, remains hooked to Charles Darwin as the two great binary stars of Victorian science. Right. Thank you. So now I suppose questions? All right.
I think we do have time for some questions, so.
Okay.
If there are any in the audience. If no questions.
Okay. All right.
Oh, come on, right over
Okay.
So, in all this, do you have any record of the sister being part of any of this conversation?
Oh, of Carolyn Herschel. Not as far as I'm aware. I think Carolyn she must be dead by now. By 1859? Yeah, so I'm not sure. I mean, Carolyn was obviously sort of a great astronomer in her own right. She lives to be sort of 100, but I'm sure that by 1759 she would have passed away. She almost certainly would have passed away by then.
I don't mean it this year, I mean in any of this conversation.
Oh.
Any records of her having an opinion one way or another.
On what? On
On the role of, is ultimately what we see explained, how important was regularity in the law?
I see what you mean. On that, I'm not particularly sure. I mean, from what I've read about kind of the Herschels, and I mean, I haven't seen her, whether she has any particular sort of philosophical view on this at all. But she might have done. I just don't know.
Did Herschel and Darwin ever communicate after that?
Oh yeah, I mean, the thing is, they were never particularly close. I mean, they're different generations. Herschel actually writes. His only public comment on this is a footnote to his work, to a book on physical geography that he writes. And he says that, again, he doesn't like the recourse to sort of irregularity, that there needs to be something to explain sort of order, and he doesn't think that natural selection can do it. But he also is quite clear at saying that while he doesn't agree with Darwin's theory, he doesn't consider it to be scientifically illegitimate either. And then at that point, that's it, and he doesn't really talk about it further. I mean, at this point, he's an old man by this point, and this is something that he clearly doesn't want to get into. I mean, we have some of the letters where he talks about this privately, but publicly he keeps quiet.
Were there other famous scientists who didn't agree with Darwin at the time?
Well, yes, eventually. I mean, it's interesting. What happens is the Origin of Species published in 1859. Darwin has sort of high hopes for it. And it's immediately controversial. I mean, it's a bestseller, people are talking about it. But by 1863, he's writing to a good friend of his, Joseph Hooker, saying, there's a half a dozen men in England that would accept evolution or at least go public with it. So he's really quite sort of upset about this. And it's his close allies, and he's not really convincing anybody for the first several years. And then what's remarkable is in 1868, he writes the same correspondent, the botanist Joseph Hooker, saying, now everybody accepts sort of evolution. So what you end up having is this delay over a few years. And then basically by the time you get to 1870, everybody is an evolutionist who is a scientist except for essentially the older generation. And then when they die off, then that's it. There's no more essentially scientific sort of opposition to evolution. And even the people that are sort of anti-Darwinists in some sense, become sort of evolutionists, like Richard Owen, Darwin's great sort of opponent. I mean, he's an evolutionist. He just doesn't, he just attacks Darwin's particular explanation for evolution.
In the back, we've got one.
Yeah.
You mentioned that Humboldt was inspired by Charles Darwin, and you told about Humboldt, I understood that Darwin came as a young man, came to see Humboldt as an old man, and he was very disappointed with Humboldt.
Well, see, I guess I'm not sort of aware that Darwin ever would have been disappointed at Humboldt. I mean, he certainly remained deeply impressed with Humboldt, and Humboldt was kind of writing good science right up to the end. I mean, I do know that Darwin's good friend Joseph Hooker went to visit Humboldt and was disappointed in him as a physical specimen. He expected to see this great Humboldt who could climb mountains in a few bounds, and saw this, and he said, this paunchy little German, and was sort of disappointed by that. What Darwin would, I don't know. I would have to actually see kind of the reference, because I don't know what Humboldt could have done or would have done that would have disappointed Darwin, because Darwin remained kind of enthralled to kind of Humboldt's idea of understanding the natural world and the universe as a unity. So I would have to. I'm sorry, I can't answer that better. Yeah.
You said on his death, he was kind of seen as like the Christ of science. His views changed over time. Could you explain that a little bit more, how they viewed him at the time of his death?
Well, I mean, one of the things actually that the reason, first of all, once evolution became generally accepted within the scientific community, the establishment within the Church of England, for the most part, sort of went along. I mean, that's one part. Another part is how that they established kind of Darwin as at least this true spirit is Christ is not in his beliefs, but in his behavior. That Darwin showed humility, he showed patience. In the sermon, he said that he was aware, that Darwin was aware that people would be offended by these ideas, and he put them forth, but he did so in a sort of respectful way, that he carried out his science over the course of many years and he tested it. And that actually kind of goes to another major theme of my research, where what I argue is if you want to understand the reconciliation of science and religion in the 19th century, you're looking in the wrong places to try to reconcile scientific theories with religious doctrine. That's not where it took place. Where it took place is in reconciliation of scientific behavior. Now, if you look at the behavior that Herschel sets forth as essential to the inductive method, it's patience, it's humility, it's giving up ideas if nature proves them wrong. It is long continued effort, and then you look at the arguments of what it means to be a good Christian, his patience and his humility. And so I'm absolutely convinced that that's the point of reconciliation, that it's not a coincidence that they would see as that the moral qualities of good scientists and the moral qualities of the good Christian are exactly the same, and so that they reconcile it that way, rather than trying to sort of align Genesis with a particular theory of sort of geology. At least that's the way that Herschel and the kind of the larger group of gentlemen scientists sort of tried to accomplish it. And that's where they would see Darwin in his behavior rather than his theories, and that's what they're praising. Yeah.
So do you think that royal or upper class patronage at this point helped to sort of take these theories and there's a Bellon being some popular type?
Well, I wouldn't necessarily say sort of patronage necessarily. I mean, what you have happening is the kind of the leading men of science, the people that are in establishment, particularly in Cambridge and Oxford, but also in London, the British Association for the Advancement of Science, and people would be leaders there, Edinburgh, and so that once the scientific community sort of began to coalesce around Darwin, what this means is that other people, essentially who weren't scientists, began to sort of take their lead from that. But also important to recognize that what Darwin was doing, this was not a new problem, that science and astronomy in the 18th century had to be sort of reconciled. Science and geology in the 19th century had to be sort of reconciled. And so there's this long sort of process in which scientists make new discoveries and they are sort of reconciled within kind of the establishment view. And I think that's happening, and so that's the kind of that's the process, and even the fact that Herschel does Darwin a little bit of favors when he comes out and says, in his footnote, by saying at least this is legitimate, and I mean that's a big deal, because therefore he gives people essentially permission to agree with it even if he doesn't, and the younger generation really come to Darwin. And then that becomes, that is something that, also one of the things I would say that what Darwin does, and this is also part of my research, is that the book that he publishes after The Origin of Species, it's not The Descent of Man, it's not The Variation of Animals and Plants Under Domestication, these other big theoretical blockbusters. It's a small little book on orchid fertilization. And this seems kind of odd. You write the most important work in the history of biology, and the next thing you do is fertilization mechanism of orchids. That's weird, right? But what he's doing there is he's showing that the theory of evolution by natural selection can become a research tool, that if you want to understand this really interesting biological problem, and fertilization mechanisms of plants is an interesting biological problem, he's able to understand plant fertilization better than any other botanist who'd ever lived. Not because he's a better botanist, he wasn't, but because he had the theoretical structure to kind of understand the relationship between orchid form and function and reproduction and sort of ecology. And kind of what I would argue is that that's what kind of happens that causes this shift, that once scientists begin to see that it is useful, that you can put it to work, then that really opens up the kind of the explanatory potential of the origin where it didn't have originally when it wasn't tied to the production of new knowledge. Yeah. Oh, yes. Darwin's, discovered the principles of natural selection first, didn't publish it, then later on, Alfred Russel Wallace in the Malay Archipelago, modern-day Indonesia, sort of comes up with this as well. And so the answer to the thing is, in fact, if we look at kind of who they were reading and how they were responding to it, the overlap is almost sort of remarkable. It's almost entirely the same people. They're reading Lyell, they're reading Herschel, they're reading Cuvier, it's coming up. They're reading Malthus very significantly. So it's almost a one-to-one overlap, or at least the Venn diagram is almost just a circle in that case.
Okay, one more question here. If we've got one more, and then we'll conclude this session. Or maybe we'll just conclude it now.
All right, well, thank you very much.
Thank you, Dr. Bellon. As a token of our appreciation for your talk, we have a very nice little plaque here for you that we want to recognize. And I found it immensely interesting. So thank you again. We appreciate it.
Okay, thank you very much.